Okay, so today we're going to continue working with quadratics. So we're going to take a look at the most basic form of a quadratic, which is what we call the parent function. So we're going to look at the parent function of a quadratic, okay? So before we go over this, I want you to pause the video and I want you to go ahead and fill out this chart and go ahead and plot the points. All right, here's our function, f of x equals x squared. So if x is -4, what is f of x? Remember, f of x is the same thing as us saying y, right? So if I put -4 in for x, what do I get for an answer? So pause the video really quickly and go ahead and get all of these points. All right, hopefully you paused the video and you got all the points. So we would have 16, 9, 4, 1, 0, 1, 4, 9, and 16. All right, so if we connect, so it says we need to plot these points. So -4, 16. Remember the first one is left and right, second one's up and down. So -3, 9, -2, 4. So make sure that you guys are plotting these as I'm plotting them, or if you've already plotted it, you can move ahead in the video if you would like. 3 would be 9, and 4 is 16. Okay, so we've plotted our points. So now it says connect the points with a smooth curve. What shape is made by the points? So if we connect these, smooth curve, right? No points. So we want this to be curved like this. All right. Now, what shape do we get here? Right? We get a U shape. Okay. Now, this is different from a V, right? So absolute value, if we were to graph this, like this, make this graph, we would end up with a V. Like it has a very distinct point down here. Now, this one is more curved. This is a U. All right. This is called a parabola. All right. So when we graph quadratics, we always get a U shape, which is called a parabola. All right. What is the lowest point on the graph? So the lowest point on the graph is going to be right here, right? It's at 0, 0. This is our minimum, right? And the minimum is the value of our vertex. It's the value at the vertex, right? This is our vertex, so this is at the very bottom. It is our minimum, all right? Now, if this parabola was upside down and like this, right, which sometimes it is, then our vertex is going to be our maximum point. So your vertex is always going to be your max or your min, but this one asks for lowest. What is the domain of f? So domain is all of the x values, meaning what am I able to plug in for x and get an answer where I would not get an error message on my calculator, right? So when we're looking at the graph, we're looking from left to right. So how far left to how far right does our graph go? Now you'll look at this, I could extend this, right? I could do this 5, 6, 7, I could keep going. And as I keep going, this graph would just keep getting wider and wider and wider and going higher and higher and higher, right? So how far left to how far right my graph? My graph goes forever to the left and forever to the right. Meaning I can put in -100 in for x and get an answer for y, or for f of x, right? And I could put in 1,000 for x and still get an answer. So it doesn't matter. There's no restriction for how far left or right my graph is going to go, or any restriction with plugging in x. Now, the only time when you would have a restriction with x, if you have something like this, right? We can't have 0 on the bottom, or something like this, where here I couldn't have 2 on the bottom, so x could not equal 2. Right? So that's when you're going to have some restrictions with your domain. With parabolas or with quadratics, we're always going to have, we can have any value, we can plug any value we want in for x. So we say that's all real numbers. All right, and another notation for that, we'd say we're going from -infinity, right? This is a number line, this is going to -infinity, this is going to +infinity. So we say -infinity is less than x, which is less than +infinity. Another way to write this would look like this. Okay, and we put them in parentheses because we're not actually talking, infinity is not an actual location on a number line, so we put it in parentheses, okay? And if we wanted to include the number, I'll show you that in a minute, we're gonna use brackets, and we'll go over this more as well. All right, then it says, what is the range of f? So range is how low to how high your graph goes, okay? Now, on this one, we do actually have a point where it is the lowest and it doesn't go any lower, and that's here at your vertex, right? That's what we said, your minimum is always gonna be at your vertex. So here is my vertex. Now, when we talk about range, we're talking about our y values, right? So I want the y coordinate of my vertex. So the y coordinate of my vertex is just 0, okay? So we're just gonna say that all of our y's are gonna be greater than or equal to 0, right? Every y value, if I pick any point on this curve, right? If I pick this point, if I pick this point, if I pick this point, the y value will be greater than or equal to 0, okay? Another way, another notation for that would be that we are going from 0, and we're including the number 0, so we use a bracket, and it goes to infinity, and we use a parentheses for that. This means it's not included. The bracket means we're including the number 0, so that includes the line underneath here. All right, where is f decreasing? Where is f increasing? All right, so we read a graph from left to right, okay? So as we're moving from left to right, I start here, I'm going down, 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 get to this point, and suddenly I turn, and now I go up, right? So I'm going to be decreasing when x is less than 0, right? All of these, when x is less than 0, I'm decreasing. We hit the vertex, and we turn, and we start increasing. So we increase when x is greater than 0. All right, so we're decreasing, we're going down into the curve, and then going up. All right. Does f of x have a constant rate of change? Now, constant rate of change, that's linear, right? We have slope. So constant rate of change is also slope. We don't have a slope on this because we have a curve, not a straight line. Okay, so do we have a constant rate of change? No. The graph is not linear. All right, and then sometimes it's steeper and sometimes it's not as steep. Like you can see here, this isn't that steep, but then suddenly we get here and we start getting more and more steep, right? So as we're moving away from the vertex, we are getting more steep, okay? Let's see, number 7. So number 7 says, use a dashed line to draw the line of symmetry on the graph. All right, with parabolas or with any quadratic, you're gonna have, it's symmetrical. So the line of symmetry is where it cuts the graph in half, and right, we could fold it and the two sides would be the exact same. Your axis of symmetry, or your line of symmetry, I'm sorry, goes right through your vertex. Okay, so this right here is your line of symmetry. And on a graph, on a quadratic, right here where it says line of symmetry, another name for that is axis of symmetry. All right, so we have an axis of symmetry. We're cutting this graph directly in half, and it always goes through your vertex. Good thing if I can spell. Goes through vertex. Okay, so I could cut my graph in half. I could go straight down the middle, going through the vertex, and that's called your line of symmetry. All right, and then part B, it says give two x values that have the same output. What do you notice about the location of the x values in relation to the line of symmetry? Okay, so we need two x values that give us the same y. So if we look at our chart here, I'm looking for two numbers that give me the exact same y, and there's actually several of them. So let's just pick here, let's do 3 and -3, right? So when I plug in -3, I get 9. When I plug in 3, I get 9. So both give me the same output, even though we have different inputs, right? Okay, so we have 3 and -3, right? Both equal 9. Now, in relation to the axis of symmetry, so in relation to this, here are my 2 points. What do we know? What can you tell about this point and this point in relation to this line? Yeah, they're the same distance from this line. So from here to here, it is 3 units. From here to here, it is 3 units. So they are the same distance from your axis of symmetry, right? That's how you know that's your line of symmetry. So they are the same distance away from the axis of symmetry. And again, axis of symmetry is just a fancy way of saying the line of symmetry, okay? All right, so let's take a couple quick notes on this. So that's what the graph looks like. Every parabola, again, this is called your parent function, meaning this is the most basic of all quadratics, okay? And every quadratic is derived from the parent function. All right, so let's flip it on over. Let's take a look. All right, so a couple of just really quick notes, things that you need to know. All right, so the graphs of all quadratics functions are parabolas. Okay, and what that means is no matter where it is on the graph, it's going to be that U shape, and then you can always cut it down the middle, and you're always going to have a vertex there. The vertex can be your minimum, and in some cases, your vertex is going to be your maximum point. And we always have a line of symmetry, which we call axis of symmetry. Okay? All right, also, the next part. So y equals x squared, that's your parent function, and that's the most basic quadratic function. All right, for these, your domain for all quadratic functions is always going to be all real numbers, right? Which is that -infinity to +infinity, okay? And then your range is going to depend, all right? So range, in this case, the one that we talked about, so when your parabola is going facing up, your range is y is greater than or equal to 0. And when your parabola is facing down, y is less than or equal to 0. Well, it really depends. This point can change depending on where it is. So this would be your y coordinate of your vertex, okay? So that too. So that will be your y coordinate of your vertex. So I'm just giving you an example. If it was right here, if that's where it was on the graph, and again right there, if that was where it was on the graph, okay? So that's just an example there. All right, also your slope gets steeper as you move away from the vertex. Okay, so your slope, so here, your graph is going to become more steep as you move away from your vertex, is farther away. So this isn't as steep, and as you get it, you'll see that you'll start getting more and more and more steep. Okay. All right, so let's take a look at this. All right, so for f of x equals x squared, f of a equals 10. So what they're saying is that we plug in some number and my answer is 10, right? So I have 10 equals x squared. Okay, so this is telling me when I plug a in, my answer is 10. So I put 10 as the answer. Here's my function. So how do I get rid of, or what's the opposite of squared? So like adding and subtracting are opposites, multiplying and dividing are opposites. So then with squared, square roots are opposites. So you would take the square root of both sides, and we get that x equals approximately 3.162. Okay, that's an estimate there. So then how do I find, so now I want to find f of negative a. So I'm plugging that back in. This is my a, right? This is what it equaled. So I'm plugging that back in. So I have f of a equals, f of negative a equals 3.162 squared. And that just gets me back to positive 10. Okay, it's just showing you how we take the square root and we take that number and plug it back in. Also, if it's negative and square it, we're getting the same answer. Okay, and we're going to go over more of that in class. All right, it says let f of x equal x squared, which is greater, f of 7 or f of negative 7? So if I plug in 7 squared gives me 49, and if I plug in negative 7, that also gives me 49. So they are equal. They are actually equal to each other. Okay, because remember, the square of any number, positive or negative, is always going to be positive. So which is greater, f of negative 10 or f of 3? So negative 10 squared, that's going to give me 100. 3 squared is going to give me 9, right? So the f of negative 10 is larger, or is greater, sorry. That is greater. Again, when you square a negative, it becomes a positive. All right, does f of x equals x squared change faster between x equals negative 4 and x equals negative 3, or between x is negative 3 and x is negative 2? Explain. All right, so remember we said the graph, the slope gets steeper the further away from the vertex, right? So these two would be further away from the vertex than the other two. So this is going to be faster changing because it's steeper. So this would be steeper. So therefore, change faster. All right, what is the constant difference of f of x equals x squared? So this is talking about yesterday, right? When we talked about our second difference. So here, again, if we just had this 0, 1, 2, 3, right? This would be 0, 1, 4, and 9. If we look at the first difference, we added 1, we added 3, we added 5, and then if we look at the second difference, added 2, right? So right here, this is your constant second difference. Remember we talked about that yesterday in the chart. So our common second difference is going to be 2. Okay? All right, this is a quick run through. We're going to go over this more, but this is just giving you the basics of the graphs of a quadratic function.